This is my fourth video lesson for Unit 13. In this lesson, we're going to talk about pH. Go to page 17 in the class packet. Take a moment to analyze this diagram for acidic, neutral, and basic solutions. Question 1. Compare the concentration of hydroxide and hydronium in a neutral solution. If we look at the neutral solution, the concentration of hydronium and hydroxide are equal. In terms of ion concentrations, how are basic solutions different from acidic solutions? If you look at the basic solutions, it has higher concentration of hydroxide, while in acidic solutions, they have higher concentrations of hydronium. Question 3. Compare the concentration of hydroxide and hydronium in acidic solution. In an acidic solution, it has a higher concentration of hydronium and a low concentration of hydroxide. Question 4. Neutral solutions have a pH of 7, while acidic solutions have a pH less than 7, and basic solutions have a pH greater than 7. Predict which ion is pH dependent on. pH is dependent on the hydrogen ion concentration. We will discuss how pH is calculated from the hydrogen ion concentration in this lesson. Learning target. At the end of the lesson, I'll be able to analyze pH and pOH in terms of hydrogen ion concentration. Homework PME number 4, which be a Junopod based off this lesson. pH is the power of hydrogen and it measures the hydrogen concentration in a solution. Just a reminder, H plus aqueous is the same as hydronium. Bracket H plus means concentration of hydrogen ion. There are two equations regarding pH. pH is equal to the negative log of the hydrogen concentration. Or if you want to solve for the hydrogen concentration, is 10 to the negative pH. pOH stands for the power of hydroxide and it measures the hydroxide concentration in the solution. Bracket hydroxide stands for concentration of hydroxide ion. The two equations are pOH is equal to the negative log of hydroxide ions, and to solve for hydroxide ions is 10 to the negative pOH. On the regions, they're more likely to ask about pH and hydrogen ion concentration than pOH. Here's a diagram showing how pH, pOH, hydrogen and hydroxide ion concentrations are related to each other. The pH scale measures how acidic or basic a substance is. Alkaline means basic. If the pH is less than 7, it is acidic. If the pH is greater than 7, it is basic. At pH of 7, it is neutral. This is only true at 25 degrees Celsius. We will explain why later on in the lesson. Here are some key equations and concepts. At 25 degrees Celsius, the product of the hydrogen ion concentration and the hydroxide ion concentration is 1 times 10 to the negative 14. pH plus pOH is 14. When hydrogen ion concentration is equal to the hydroxide ion concentration, it is neutral. If the hydrogen ion concentration increases, then pH will decrease. If the hydrogen ion concentration decreases, then pH will increase. If the hydroxide ion concentration increases, then pH will increase. Hydrogen ion concentration is inversely proportional to hydroxide ion concentration. Let's prove key equations number 1 and number 2. Let's say water dissociates into hydrogen and hydroxide ions. We know the pH is equal to the negative log of H plus. 10 to the minus pH is the hydrogen ion concentration. So when pH is 7, the hydrogen ion concentration is equal to 10 to the negative 7. When pH is 7, it is neutral. Hydrogen ion concentration is equal to hydroxide ion concentration. So if you were to multiply the hydrogen ion and the hydroxide ion concentration, you will get 1 times 10 to the negative 14. To prove equation number 2, you have to use one of the properties of logarithms. So we know from the first equation, the product of the hydrogen and hydroxide ion concentration is 1 times 10 to the negative 14. Then we take the negative log of both sides. Using the property of the log, we can convert this to negative log of hydrogen ion concentration plus the negative log of hydroxide ion concentration. The negative log of 10 to the minus 14 is 14. We know that negative log of H plus is pH and negative log of hydroxide is pOH. So pH plus pOH is equal to 14. Learning check number 1. A substance has a hydrogen ion concentration of 0.1 molar. What is the pH? Pause the video and resume as completed. To solve for the pH, we have to use this equation. Negative log of 0.1 is 1, so the answer is choice 2. Learning check number 2. Add HCl gas is added to water. The pH of water solution does what? Pause the video and resume as completed. HCl in solution is considered an acid, so the pH will decrease. Learning check number 3. An aqueous solution has a hydrogen ion concentration of 1 times 10 to the negative 8 moles per liter. Has a pH of what? Pause the video and resume as completed. So we have to take the negative log of the hydrogen ion concentration, which is 8. pH of 8 is considered basic, so the answer is choice 3. Learning check number 4. A solution at 25 degrees Celsius has a pH of 7. Contains what? Pause the video and resume as completed. At pH of 7 at 25 degrees Celsius, it is considered neutral. So there is equal concentration of hydrogen ion and hydroxide ion concentrations. So the answer is choice 3. Check of understanding number 1. Based off this equation, if the temperature increases, what happens to the ion concentrations? This is based off the equilibrium unit. When temperature increases, energy increases, so you can shift to the opposite side of energy. So the ion concentrations will increase. Check of understanding number 2. Is pH dependent on temperature? We know pH is dependent on the hydrogen ion concentration, and from the previous question, when temperature increases, the hydrogen ion concentration also increases. So pH is dependent on temperature. Check of understanding number 3. Can a neutral solution have a pH not equal to 7? Yes, it can, because neutral is defined as when H plus concentration is equal to hydroxide ion concentration. Since pH can change because of temperature, as long as the H plus and hydroxide ion concentration are equal, that pH will be considered neutral. It just so happens at 25 degrees Celsius, pH of 7 has equal amounts of H plus and hydroxide ions. Just to review, pH is dependent on the hydrogen ion concentration. Each pH factor corresponds to a factor of 10. Why is that? Because logarithms are base 10. So which is a higher concentration? 10 to the minus 9 or 10 to the minus 8? 10 to the minus 8 is a higher concentration because 10 to the minus 8 is a bigger number. So we know that the hydrogen ion concentration is equal to 10 to the minus pH, and we also know that the product of the hydrogen and hydroxide ions is 10 to the minus 14. So let's complete this table to show that each pH factor corresponds to a factor of 10. At pH of 7, using this equation, the hydrogen ion concentration is 10 to the negative 7. Using this equation over here, the hydroxide ion concentration is also 10 to the negative 7. If we look at pH of 6, the hydrogen ion concentration will be 10 to the negative 6, and the hydroxide ion concentration will be 10 to the negative 8. If we compare the hydrogen ion concentrations of pH 6 and 7, the factor is 10. That means pH of 6 is 10 times more acidic than pH of 7. Let's look at pH of 5. It has a hydrogen ion concentration of 10 to the negative 5 and a hydroxide ion concentration of 10 to the negative 9. If we compare pH of 5 and 7, the factor is 100. That means pH of 5 is 100 times more acidic than pH of 7. At pH of 4, the H plus concentration is 10 to the negative 4, and based off this equation, the hydroxide ion concentration is 10 to the negative 10. If we compare the hydrogen ion concentration of pH 4 and 7, it is a factor of 1,000. That means pH of 4 is 1,000 times more acidic than pH of 7. We can complete the rest of the table using this pattern. For pH 8 to 14, everything's in reverse. So at pH of 8, the hydrogen ion concentration is 10 to the negative 8, and hydroxide ion concentration is 10 to the negative 6. If we compare pH 7, 8, pH of 8 is 10 times less acidic than pH of 7 because pH of 7 has a greater hydrogen ion concentration than pH of 8. Let's complete the rest of the table using this pattern. So as you can see, each pH corresponds to a factor of 10. Check if understanding number 4, fill the blanks with greater or less and the factor. I'm going to do one question and then you can do the rest on your own. The hydrogen ion concentration in pH of 6 is greater than the hydrogen ion concentration in pH of 7 by a factor of 10. Try to do the rest of the questions by yourself. Resume the video once you complete it. Here are the answers. Learning check number 5, the pH of a solution is 7. When acid is added to the solution, the hydronium ion concentration becomes 100 times greater. What is the pH of the new solution? Pause the video and resume as completed. Since the hydronium ion concentration increased, the pH must have decreased. Since pH is a factor of 10, 100 divided by 10 is 2. So pH must have went down by 2. So the answer is choice 2, 5. Learning check number 6. As the pH of a solution is changed from 3 to 6, the concentration of hydronium does what? Pause the video and resume as completed. From 3 to 6, the solution became more basic, so the hydronium concentration should decrease. Since the pH went up by 3 and each pH is a factor of 10, the concentration of hydronium must have decreased by a factor of 10 to the third, which is 1,000. So the answer is choice 4. Learning check number 7. Given 0.5 molar of HCl, what is the pH? Pause the video, resume as completed. We must first determine the hydrogen ion concentration. Since HCl is a strong acid, it will dissociate completely, 100%. So if we have 0.5 molar of HCl, we basically have 0.5 molar of each of the ions. So to solve for the pH, we need to take the negative log of the hydrogen ion concentration. So negative log of 0.5 is 0.3. So the answer is choice 2. You can only do this if this is a strong acid or a strong base. If it was a weak acid or weak base, there will be equilibrium and you have to use the Rice table to calculate the H plus ion concentration. Learning check number 8. What is the pH of a 0.01 molar solution of KOH? Pause the video, resume as completed. So the first step is to figure out the concentration of the ions. Since KOH is a strong base, it dissociates completely, 100%. So if we have 0.01 molar of KOH, we basically have 0.01 molar of each of the ions. Notice that we're given hydroxide, not H plus ion. Therefore, we need to first calculate the POH. So negative log of hydroxide ions concentration is POH. So the negative log of 0.01 is 2. We know that pH plus POH is 14. Since POH is 2, pH has to be 12, so the answer is choice 3. Here's a summary slide. The acidity and basicity of a solution can be expressed as pH. At 25 degrees Celsius, if the pH is less than 7, the solution is considered acidic. If the pH is equal to 7, it is neutral. If the pH is greater than 7, then it is basic. As you can see on this pH scale, when something is acidic, there's a higher concentration of H plus ions. When something is basic, there's a higher concentration of hydroxide ions. And when it's neutral, there's equal concentration of H plus and hydroxide. 1 pH unit corresponds to a factor of 10 because of logarithms. This concludes the video lesson. Remember to complete the Junipod homework.